In this video we will learn about the chain rule, and we will see that how a function having multiple variables can be differentiated. Let us start with an example in which we will take three variables that are interconnected with each other. Specifically speaking, there is a possibility of indirect dependence of one variable on another. So in this case there will be indirect dependence. How? Let us see, because as you can see x will affect y here and y will affect z here. In other words, here we are saying that x is determining y and then y is determining z. So in this case we don't have one function, we have two functions, and they can be brought in a composite form. They can be collected together in this form, and here the dependence of z is via x, and which is starting from y. So y is affecting x, and then x is affecting y, and y is affecting z. So it means that finally x is affecting z, but via y. Y is that variable which is playing the role of an auxiliary variable in this situation, which is just helping the relationship from x to z. Now here if I take the derivative of this composite function, it will look something like this. What you can see here is that we are trying to observe the effect of x on z, that is derivative of z with respect to x. Now in this case I have written it equal to the product of these two terms, and if I cancel these two terms they will be equal, that is dz over dx will be equal to dz over dx. It means that dy is here for auxiliary role, just like I said before. It is helping to explain the situation. It is only helping, it is not the main variable. The change in x yields or causes a change in y, and that change in y causes a change in z. So it's a kind of chain reaction. We have a kind of chain. This is why it is famous as chain rule. Now there can be more than two functions. Here we had two functions, but now we are assuming that there are more than two functions. So z is dependent upon y, but y in turn is dependent upon x, and x in turn is dependent upon w. So in this case w is causing x, and x is causing y, and y is causing z. So you see there are four variables and there are three functions that are connecting the relationships between these four variables. This is the same thing written in different words, that dependence of z on w via y and x respectively. Now we are going to develop the chain rule for this triad of the functions in which there are four variables. So after scrolling it a little bit, now we can see the complete result, that the effect of x is to be observed on z, but it is happening in such a way that there are other variables involved in the process. So now we can see the whole formula. The effect of w is to be observed on z. Here it should be w, so we should be mindful of it, that we are trying to observe of effect of w on z. Therefore w is affecting x, and x is affecting y, and y is affecting z. So in this indirect way the whole relationship will be explained. As you can see, change in w will cause some change in x, and change in x will cause change in y, and change in y will cause change in z. So this was a situation where we had 3 variables and we had 4 functions. So in this situation, there are 4 variables and there are 3 functions. Now we can do this in a mathematical way. For that, definitely we need some numerical situation that we can see here. We are given a few functions that we need to differentiate, and for that uh, we are going to use the chain rule. As you can see, y is causing z here, but y is being caused by x. So x is bringing change in y and y is bringing change in z. So finally the effect of x can be observed on z. So the method of doing this kind of situation of functions is that we take the derivative of the two functions separately. As you can see, this function is differentiated with respect to y, and this function is differentiated with respect to x, as the differentiation is done with respect to the independent variables respectively. Once we have found the derivatives of these two functions, we can simply put them into this formula, which is showing the effect of x on z via these two derivatives, which are being multiplied under the light of chain rule. We have substituted the values. The value of dz over dy is this, and dy over dx is 2. So multiplying these, we get 12y, which is the effect of x on z. However, there is something that we need to improve in this situation, because here we can see the effect of x is to be observed on z, whereas here the answer is in terms of y, which, as you remember, is just a helping variable and we don't need it as such. So we are going to bring x in its place, and this function was given in which instead of y we can write this term, which is in terms of x. So this term here is now written. Instead of this y, we are writing this value of y, which is in terms of x. Multiplying these, we get this answer. Now we are satisfied with the answer because it is telling us about the effect of x on z and not the effect of y on z, or any answer which is in terms of y. So the answer now is in terms of x, which is acceptable. So in this way, the chain rule can be applied in a situation where there are multiple functions and definitely there are more than two variables, and there is indirect dependence of the first variable with the last variable, whereas in the middle there can be other variables. For instance, if x is there, there can be a few variables that can determine the indirect dependence of one variable on another. So this is what chain rule is, and this is how we can use it in some mathematical situation. And in the next lecture we will learn about the economic application of chain rule.